So, okay. Now, as for today, how many economists do we have left? 1, 2, 3, 4. Oh, good. And when I'm done, I want you, if I don't remember, I gave this presentation to Gail Gerard yesterday, who's an extremely well-known economist, and I want to tell you what he said. So, let's go here. A few flyers for the journal and my latest book. So, now, first of all, I'm an ecologist and not an economist at all. I was trained in physics, chemistry, biology, geology, hydrology, the physical sciences, and I did mostly field work, as you who were here for my earlier talk know. And then I got interested in making models, and I made a few models I thought were okay. But I found in ecology in general, most of the models that were there had no basis in reality. Anybody interested in that question, I'll send you some papers on that. But the logistic curve, which is heart and soul of a lot of population biology, no evidence of it working in nature. You can make it work in the lab. Locke of Voltaire, you know, hares and lynx, rabbits and cats. The lynx data is from Western Canada. The hares are from Eastern Canada. Something else is making it happen. I saw some people using it here. The models used in fisheries, Ricker curves, destroyed fisheries in Canada and other places. And that's another whole long story. So I was a young professor at Cornell University then, and so I said, well, you know, nobody makes at that time decisions based on ecology anyway, and I'm going to go and learn economics because these guys get Nobel Prizes and they're smarter than ecologists, I would guess, because I was at that time not too impressed with how smart the average ecologist was. And they have models that presumably are pretty good. So I spent 8 years learning economics, especially from two of my students, Cutler Cleveland and Robert Kaufman. And I came away astonished at the models in economics were even worse than they were in ecology with relation to their relation to reality. So I'm going to give that as an introduction to what I'm going to tell you. And I think for some of you, what I'm going to tell you is going to be, I hope, shocking. So let's go on. So there have been many critiques. I'm not the only one who critique neoclassical economics and how we use it. Maybe this is the most famous one. I don't know if you have the word snow angel in French, but so here's the Pope, whom I think is marvelous, the new Pope, making a snow angel. But he has criticized conventional economics for exploiting the poor, which it does. And Pilkety, a Frenchman, got a lot of fame for writing a book, which is a little bit boring, but criticizing economics. But I feel like those criticisms, and there are many of them, are only hitting at about 10% of the problem. So here's what we're going to do. The issues are much, much deeper. And this cartoon captures it. Tell me the fairy tale about economics. So I'm going to start with telling you that. So here's what I'm saying. Many economists and natural scientists, including ourselves, and this I'm doing incidentally with my colleague Kent Klitgard from Wells College, including ourselves, consider modern economics to be an ideology wrapped in a blanket of near impenetrable jargon and mathematics with only a tenuous or at best extremely incomplete relation to the biophysical world upon which it must rest. So that's the fundamental statement, that economics must exist in the real world, which is subject to, like everything else, the laws of physics and chemistry and biology and so forth, laws or principles or whatever they are. At least you've got to think about them. And we're not alone. Some of the relatively recent winners in economics, here are some Sen and Kahneman and Stiglitz and Ackerman. Basically, they got their Nobel Prizes for work that is fundamentally criticizes conventional neoclassical economics. Let me explain. There are three main schools of economics. If you want, and since I'm in France, we certainly have to include the first one, which is physiocrats, more or less 1750. Quesnay, who was the physician for the king, Louis whatever, and wrote a lot about what's the source of wealth. We'll talk about this later. The classical economists are Adam Smith, David Ricardo, Karl Marx, and they focused especially on labor, and they were very influential. Although most people who quote Adam Smith don't read all of his works, which are, do not support conventional economics as much as many people think. And the third is neoclassical, and it was starting with the concept of marginal utility that conventional economics or classical economics couldn't explain why water, which is much more valuable than diamonds, was priced at much less. And he said, well, the first liter of water would be worth far more than diamonds to you. And so, and that has evolved into what is called contemporary neoclassical economics. Now, this is probably 30 years or 40 years by now, but Vasily Leontiev, who I think is a really good economist, surveyed the then present state of economic models and economics in general. He found them to be unable to advance in any perceptible way a systematic understanding of the operation of a real economic system. Instead, they were based on sets of more or less plausible but entirely arbitrary assumptions leading to precisely stated but irrelevant theoretical conclusions. Probably you can think about that in whatever your own discipline is. He said, he extolled other investigators in demography, sociology, political science, ecology, me, biology, also me, health sciences and engineering to help remove economics from the splendid isolation in which it is found. How much effect have words like these had on economics, conventional economics? Close to zero. But they affected me. So what is economics? Let's start with the definition of the discipline, and it's supposedly a social science. One would assume that if it's a science, that it would use a scientific method. Well, here is the answer. Economics is a study of the allocation of scarce resources among competing ends. Now, scarce resources don't mean what they probably mean to most people in this room. They don't mean water or oil or fish or soil or, you know, something I would perceive as resources. It means essentially money in your wallet. And how do you spend your money? And it's a social question. And fundamental economics is obsessed with that question to the exclusion of almost all others, in a sense. This social definition of economics, that's what I just explained. So we start with the economist's apostrophe basic conceptual model found in chapter 1 of essentially every intro economics textbook. What's that? Economists, am I correct? Yes. And what we have is A model of the economy, which has two components, hence is analytically tractable, households and firms. And the idea is that money goes around this way. Households pay for the stuff that they buy in the stores, and the firms pay households, wages, profit, and so forth. And the stuff goes around in the other way. Goods and services go this way, and land, labor, and capital go from households to firm in principle. Really. This is their model. I kid you not. Now, there's at least three basic reasons that anybody trained in real science would find disquieting at a minimum of this model, or, like me, would dismiss it entirely. The boundaries are incorrect. Households and firms, that's all. Where do firms get their stuff? Oops, don't talk about that. It breaks the laws of thermodynamics. It's a perpetual motion machine. I do not know anything in the universe that breaks the laws of thermodynamics except in the minds of economists. And its basic constructs are given as logical fiat, not as testable hypotheses. Am I correct?
No.
No. Yes?
Tested personally some basic hypotheses.
Well, good for you. Good for you. As have I. So we'll talk about that. Okay? How about the other two? Any problem with them? For the moment, okay. Now, here's another basic neoclassical model, is maybe not quite the right term, but it'll do. That this is how, in 1990, the US economy, for one person for 1 year, this is what it did, what it operated as. Capital came in, $5,000 per person, labor, 2,000 hours, came into the economy, and that generated $20,000 a year of GDP. Okay, and the numbers today would be larger because of inflation, but otherwise not. We all know that's not true. That's not an entire economy. But don't bother me with that, please. It's really kind of embarrassing. If you are a real, trained, rigorous biophysical scientist or engineer, I challenge you to look at how economics operates and tell me whether it's consistent with your knowledge. Now, what happens if I ask you personally what economics means to you? My guess is that most of you would say, as I do, what economics means to me is food on my plate, a roof over my head, car in the driveway perhaps, a lift ticket, a pair of skis. Mostly it's about stuff. And there's a great little thing to watch called It's About Stuff. And it's on my website, and it's really well worth talking about. But stuff does not enter into the neoclassical model, nor the energy that is required to generate, distribute, and whatever else stuff. The real alternative, which I have been working very hard to generate, along with colleagues like Kent, is what we call biophysical economics. We normally capitalize the P, and that's the name of our journal here, our new journal. And let me explain that to you. First of all, any questions about my criticisms of conventional economics? Yes?
I used to use the definition by Karl Popper of the science. The definition, when simplified, is something like, it's a science if it makes predictions which can be verified so that either it's wrong, where we change the model,
Yeah, sure.
or it's right and it will continue. So
And it has to be consistent.
I have never seen an economist making predictions or at least verifying that the predictions are correct.
I
So
can
what,
give you
what do you
example.
think of that?
I think it's rare, and I applaud you.
Yeah, so I can.
Would you agree that it's rare?
Sorry.
Would you agree that it's rare?
I would agree. Well, it's a long discussion. I agree with much of what you said. I would say the following. There are two fields, microeconomics and macroeconomics. Most economics today, and I myself, are interested in microeconomics. This is individual behavior. In this field, I think much can be said, tested, and it's close to being a science. In particular, you can set forward testable assumptions. I'm talking about microeconomics. Shortly, if you want to know how people behave toward car insurance, you can give predictions and so on. We understand very well how people behave towards car insurance. Now, if you talk about the macroeconomics, it's a completely different issue, and I would agree that no one understands how macroeconomics behave.
And I'm talking about the fundamental concepts that I put forth and many others. But so
In
I agree
macro.
with you, and I have written a paper where I went through the leading economics journal and looked for how many times they tested hypotheses. And in fact, I found that maybe 10%, 7%, I think, of papers did test hypotheses. And in general, they were those that tested hypotheses that were related to the fundamentals of the science did not refuted or did not support the hypothesis. So it's a little unfair for me to say, but it's the fundamental concepts that I'm worried about, not that some good economists in some places use a scientific method. Yes?
So, following this, if you understand microeconomics on the individual level and not macroeconomics on the global level, what is the purpose then of the concept of thermodynamics? Because in thermodynamics you understand the macro behavior but not the micro behavior.
Please stay in your seat. We'll get there.
Keep in mind you got to get there and 30 before the next person.
Our second... No, I've only been going 20 minutes.
Yeah, just started late.
No, but I'm not going to pay for that. That wasn't my fault. I was ready. Our second quite different definition of economics from Polanyi is economics is a study of how people transform nature to meet their needs. And that's exactly what I think we do. And this is how real economies work. I made this diagram about 30 years ago, and I've had no reason to change it. So you got to start with the energy sources. Obviously, nothing can happen in an economy or the world or anywhere else without energy. And the energy comes from the sun, from geophysical, from nuclear, disintegrations, which of course is the sun, or fusion. But so then that interacts with the surface of the Earth, where the sun runs the water cycle, which is the most important input to most economies. Think of the impact of drought in Australia. And yet it doesn't enter into hardly any economic calculation because it doesn't enter into the markets. This is a sort of a gift of nature, so to speak, but it's critical for the economy. And the sun also runs the ecosystems, natural ecosystems. It lifts the water to the mountains and pours them on Mount Snow. And in the past, some tiny percent of the biological productivity got sequestered as fossil fuels, which runs our economy today. And with some complicated ways, life and bacteria and the natural cycles concentrate minerals so that we have enough copper to mine it, even though the grade is going down. Now, humans come in here. The first step is exploitation. In each of these steps, you see energy and matter following along through the system. And so humans are exploiting the sun by growing their crops and raising their animals. and damming rivers and making oil wells and other devices for extracting fossil fuels and materials, metals for the earth, from the earth. Then there's various kinds of processing. I have here a butcher block, a sawmill, a petroleum refinery, a thermal plant, making electricity, a Bessemer steel process. Then things are manufactured, always using energy. So the materials are flowing from here, this way, and with energy being used at every step. You'd put in a heat sink like you do in an electronic circuit at each one of these steps. So thermodynamically, the energy is absolutely essential. And you go to consumption, and the neoclassical models tend to focus on this boundary about where the consumer chooses to spend his or her money, etc. And so there's our breakfast and housing and bridges and cars and so forth. And then all of it, the heat, which is in the light arrow, derived because of the second law and other reasons too, is lost. And the material goes into the trash pile. I guess we would maybe include a recycling element if we made that diagram today. Yes?
On the left-hand side, energy sources, I am afraid you need to add CO2.
It's not an energy source. It's a material source.
Or a material source if you want, but it's key for having all this.
It's right here.
The question for later?
It's here. In fossil fuels. Okay, and sun lets plants split water and...
It's a resource.
It's a resource, but it's not an energy resource. CO2.
Any atom on the table of Mendeleev is a resource in this diagram. Carbon.
Now, an equally legitimate view of the U.S. economy in 1990, for one person, the same boundaries, same as we used before, is this: the inputs are 2,500 kilograms of oil, 3,000 of coal, 2,000 of gas, hydronuclear biomass, 140 kilograms of water, 1,000 of wood, 81,000 of rock, 186 kilograms of iron, other metals 43, and soils and cement and so forth. And the output is not just GDP, but CO2, particulates, sulfur, nitrogen oxides, and polluted water. I mean, these are all part of the system also. It's not just money. Now, what humans tend to do, and I got this idea from Toole, who wrote The History of Montana, is they go through exploitation cycles. And this is simple one I did for Ecuador a long time ago, is that this is the amount of coffee that's exploited and exported, and then they used up the best soils, and other people produced coffee better, and mostly the pests came in. So they lost that. Wild pelagic fish went like this, bananas like this. This is data. The purple is farm shrimp, where they would dig out the mangrove swamps and then now they're on this one, oil. And it will probably peak sometime around now, is more or less, and what's next. So humans exploit the earth. Now, the elephant in the living room is energy. Neoclassical economics, for them, energy is a commodity, like pickles. When I first started talking about this in Sweden, economists said, well, you know, energy is just a commodity. It's like pickles. Why are you treating it specially? Now, for biophysical economics, as I will show you, is a critical factor of production, more important than capital or labor. But it's not included in virtually all economist models. In neoclassical economics, energy is unimportant because its cost share is small. We heard that yesterday. But in biophysical economics, energy is important because its cost share is small. You get a hell of a lot of bang for your buck. And what you do, it's so important and it's been so cheap, as Kerry showed us, especially recently, that's allowed us an enormous ability to do other things. And, you know, here's some simple graphs. This is the growth of the world economy from 1820 to present, and the amount of energy that's used, or it's the growth rate per year, different years. I think Gail should have put the years on this. I have a better diagram for the United States, but I didn't have a picture of it. But let's just look at developing countries. This is 1970 to 1992 when I used to work on development in Mexico. This is GDP per capita, and this is energy consumption per capita. And you can see that in order for there to be GDP growth, or associated at least with GDP growth, is an increase in energy use. And Korea, which is very successful, even the Netherlands, US is a special case that I'm not going to talk about now, but I could. And Costa Rica, where the population growth, as I said the other day, the population growth rate is the same as the energy growth rate. There was no increase in GDP per capita during this time period. I think this speaks for itself. This is change in each, and there's been a decrease in energy and oil use globally, even more going up to now, as likewise a decrease in GDP. There are many concepts of traditional economics that are much better explained from a biophysical economics perspective than from the conventional perspective. For example, neoclassical production functions, Cobb-Douglas production functions. They say, and Dennison and Solow and others write about this, productivity is a function of capital and labor. K stands for capital. The R squared is about 0.5. And they say, well, when we look at the inputs, we only can explain half of the growth of the economy. And so this is called the Solow residual, and it's assigned to innovation. Well, they say this must be due to innovation and technology and all of that. No energy in that equation. Now, if you asked a physicist, how do you make something, just something, you would say, well, you take some stuff and you add some energy and you generate, and you have a plan and the technology to do it, and you make something. Doesn't enter into the head of an economist, apparently. Now, my good friend Reinhard Kummel has done an analysis. Now, the point is, as the GDP has increased, then let's approximately like so, and if you do the Dennison analysis, you can only explain half of the growth. But when Kummel adds in energy, he gets essentially 100%. And energy is more important than either capital or labor in these equations. Obviously, you need them all, but energy is not in the production functions. What physicist would tolerate somebody saying, I'm going to do something without energy and without the degradation of that energy through the laws of thermodynamics? You'd be thrown out of the building.
Sorry again, which energy are you talking about? The primary energy or the consumed energy?
It's as thermal. Total energy used in the economies that we're talking about. Just add them up, count them as joules. Not including sunlight. Fossil and nuclear. So, and I can talk about that if you want, but I don't want to now. Japan, the same. Germany, the same. So Kummel has destroyed the concept of production functions as used in conventional economics. US, a little bit different. And now, how do we do things in our economy? And this is Signorini's wonderful painting. The riverbank shows some rich guy with his daughter walking along here and a dog, and these guys pulling a barge in the vicinity of Florence, and probably moving coal. Now, that's how we used to do things. Now, obviously, the output of a human, 100 watts or so, is not a lot. Here, I showed this the other day, it's such a marvelous picture from Mario Giampietro. And this is a 33 horsepower harvester with requiring 5 people here and plus stable boys and to grow the other farmers to grow the fodder for the horses. They're actually mules, etc. And here we have today one worker using a 200 horsepower harvester. His muscles have been made much bigger through the use of fossil fuels. Hence, he can do more economic work.
I'm sorry, but this energy you are referring to has been created by the economy too. Huh?
I would say it was created, speaking as an atheist, by God. We've exploited it. And the reason it's cheap to us is we pay only for the exploitation. Whether you have, of course, there's hunter-gatherers have economies too. I don't disagree with that. And maybe that's my point. But humans did not create that energy. They merely exploit it. And I also showed this the other day. This is coal. Now, I'm born here in 1943. Look at this, 8-fold increase during my lifetime of the global use of fossil fuels, coal, oil, gas, nuclear, hydro, and this still very little bit from new solar technologies. We need to update this graph, but here's the idea. Now, so the first thing is energy is essential for the economy, and economists don't think about it except rarely in terms of price. Okay, now, where does labor productivity come from? Well, early work with Robert Kaufman was fuel use per worker hour and labor productivity. They were the same thing. And then it started going down in the energy crunch of the 1970s, and an embarrassed President Reagan, and President Reagan stopped collecting the data. So, shoot the messenger. Phillips curve in economics, which shows that there's a relation supposedly between unemployment and inflation. And when inflation was high in the 1970s, Jimmy Carter was convinced by his workers, by his economic advisors, to, in order to decrease inflation, increase unemployment. So it cost an enormous amount of unnecessary misery. But in fact, here's the data before the 1970s. It follows the Phillips curve pretty well. And then when we had the energy crisis, the curve had no relevance. That's because energy was the important determinant of both employment and of inflation. I can give a longer explanation if you want, but that's the idea. The conventional economics fails as it often fails. The stock market goes up and down. But if you go back as far as the data goes for the Dow Jones 1914 to 2010, we need to update this, and you look at the stock market is just prices, so you have to correct for inflation. So this is the stock market corrected for inflation. This is Dow Jones's industrial average is supposed to look at industrial production, and here's energy used in the industrial part of our society. And so they both have the same slope over the same time, but there's a lot more irrational exuberance and the opposite in the stock market. It has a psychological factor. So I would say now that the stock market's too high and is going to come back there eventually, is my guess. It's a prediction, I suppose. Where does wealth come from? We use money normally. Money is just a means of exchange. And printing more money does not make us richer, but just leads to inflation. Some people think we should use a harder means like gold. And we've fought over gold a great deal. The Spanish came and raped the Americas to, where's Pedro, not here, to get the gold, etc. And then it ends up in the churches up, you can't see the gold up here very well, but oh, there it is. Whoop, just go to the Vatican. And we know that money is not, and gold is not a good index either, because when the Spanish brought the gold back from the New World to the Old World, they doubled its content and halved its value. Same with silver, except tripled. So the real wealth came from the work of sun, rain, and wind, and foresters, fishermen, slaves, farmers, housewives, artisans, everywhere. So we can explain all of economics this way. In 1750, the French physiocrats, Quesnay and others, said land is most important. Whoa, the classical economists came along, Smith, Mercado, and Marx. No, not land, it's labor. And then neoclassical guys came along and said, no, it's capital. But I say each of them is correct for the time, but incomplete, because land is the way you intercept solar energy, when that was the important way you derived wealth. And when we put workers together in factories to make stuff, labor was most important. And capital is useless by itself. Capital is a means of using fossil fuels. And so when you look at it this way, it integrates all economic thinking from an energy basis consistent with what a physicist hopefully would be happy with. Biophysical models tend to be much better predictors. And this most important implication of energy return on investment that we're talking about here is that there are limits to what we can do to solve the CO2 problem. And the limits we've heard again and again and again coming out of the unexpected consequences of various kinds of technology. I'll just give you one example. I made a prediction in 1984, and John Halleck is lead author on this, one of my students. And we look at the production of oil in Mexico up to 2000, I think then, and the use of oil in Mexico. And we made predictions. We made predictions based on the Hubbard curve, a biophysical model, and 3 estimates by the USGS of total energy in the ground, exploitable oil in each country. And I'm going to go through this real fast, but let's look at Argentina, where I've done a lot of work. And this was the predictions we made for Argentina in 2002, published in 2004, of its use and of the production if there's a lot of oil in Argentina, which it turned out there was, or not very much oil in Argentina using a biophysical model. And you can see we did pretty well. And we can look here, and we failed for Angola. But I'm going to just show you most of the oil-producing countries have had a Hubbard curve more or less following one of our curves, and 80% of them following the low estimate. Again and again and again. So people say, well, you know, have peak oil theory failed? No, for most countries it's right on the money. Cameroon, China we don't know, Congo maybe, somewhere, but there's such uncertainty. Colombia, right on the money, more or less. Denmark, very good for Denmark. And we can go, we've done them for all kinds. Look at Norway, that's a good one. It follows our low curve almost perfectly. The red dots are the data since we made our prediction in 2000. So we test our hypotheses, we publish them, we come back and look at the data, and we say, how often did we succeed? How often did we fail? And we find that we have about an 80 to 90% success rate. 10% we fail. What economic model can say that? Peru? No. And we can go on. And then you have a war in Syria, and that doesn't work at all. So even though we have not reached peak oil, or we have, probably, for the world, real oil we have, then for almost all countries, the peak oil model is a damn good one. Even the much maligned limits to growth. Am I out of time? In fact, yeah, okay. In fact, is a pretty good predictor even today. Most economists dismiss it, say that, but they're wrong, and they didn't look at the data. So, John Day and I did and published on this, and it's pretty good. So, anyway, here we are. Most of our economic and financial theories are derived here. Here's where we are. This is energy use or oil use or something like that over time. And this is, what economic theories are appropriate here. Well, certainly not neoclassical ones, I'll tell you that. And of course, ultimately, it's related, and we said this long ago, and there we are. So, so my conclusion is that real scientists cannot accept economics. Sorry. And there you have it. Now, I gave this talk to Gail Gerard, who's, believe me, a real economist and a very famous one, and was here the other day. I gave it to him yesterday afternoon, and I finished, and I said, well, what do you think? And I thought he was probably going to find, they said, got any questions? And I thought he was going to find some real holes in my argument. And his response to me was, I'll never forget, I don't think, is, how do we attack the fortress? Meaning, how do we get this message to conventional economists, academic economists especially, who are isolated from any other discipline in discussing what they do? In ecology, it's embarrassing because ecologists line up with economists and they say, well, here's what the ecosystem does, and the economist says, here's the dollar value, and that's it. Well, that's
All right,
essentially